my CNC router table is on its side right now, and that's because it hasn't been taken apart and had its rods and threads cleaned in probably, I want to say 10 or 15 years. So the x-axis is not moving like it used to, and I took apart the y-axis and cleaned it up real nice already. But the x-axis is more involved. In order to do that, I'm probably going to have to remove an entire one of these panels. I'll just have to take off the bed, take off the other, some screws down at the bottom, and then I'll be able to, I don't want to slide, you gotta be careful, you don't want to spin the rod all the way, this, I think it's Acme, whatever. You don't want to spin it out all the way because this is, there's a whole bunch of, it's like a ball bearing, it's like a spiral ball bearing, and if you spin the red out, all of the balls are going to pour onto the floor. And I even have proof that I made a mistake in the past, because whoops, there's one of them, alright? So they're not like big and easy to pick up. You pretty much need a magnet. So in order to not repeat myself, I'm not going to take this all the way out, I'm just going to make sure it threads easily. These though, these linear bearings, nothing will fall out when you pull the rod out. I will probably just move it back and forth and maybe tap it with a hammer and make sure everything is aligned, because there's two linear bearings, and if one of them is slightly misaligned, then you lose a lot of energy to friction. We got the y-axis up here, which I have already cleaned. I took it apart. I removed all of the old grease that was on the threaded rod, and then I also took out these and I popped out the linear bearings, and I found that one of the linear bearings was misaligned. You know, before I had to pull with all of my might to get the gantry to move. I mean, so normally you can't just get a worm gear. If you think of this as a worm gear, you can't just spin a worm gear, but because it's a ball bearing inside there, it's actually very easy. If it weren't for the resistance of this motor, I would be able to reach down and just lift the gantry up, and this would spin, the rod would spin real fast. And that's after I realigned these linear bearings. And before, like I said, I had to pull with all my might. And so I'm expecting that stepper motor to be working a lot easier now. The machine is apart enough that I can move the rods with my hand, and this seems alright, but I mean, compare it to the bottom one, which actually moves easier. So I've found that I can move just with my hand with a little bit of leverage, or maybe even tapping. If you tap up and tap down, the bearings, the rod's able to pivot a little bit, so there's a little bit of alignment involved. We'll have to make sure when we screw everything together that it's not cockeyed or, you know, up too far or down too far with respect to the holes it mounts in, right? You can't have it bent one way and then it tries to go into the hole and that puts tension. You don't want there to be any tension on anything. So the rod is very visibly pitted and to the touch it's a little bit rough. So it needs cleaning. We're gonna go sandpaper. This is 2000 grit. But first, we're gonna degrease it so that doesn't get all in the sandpaper, and we're gonna use isopropyl alcohol just on a cloth to do that. I've cleaned the rods and got some gunk off of there, and I'm still feeling that the top one is just a tad tighter than the bottom one, and I'm gonna hit it with some sandpaper now that it is clean and dry. Now that we've got the surfaces refinished, I'm putting some 3-in-1 oil, since there is kind of like a linear ball bearing. And we'll give that a little bit of motion. And the oil definitely helps a lot, but it's hard to tell. It's pretty close, but part of me still thinks that the bottom is a little bit easier to move than the top, so we'll keep working it. Do the same thing I did with the y-axis, at least on these, is pop out the bearings. And in order to do that, I got I think this is, no, it's 1/2 inch, okay. I was gonna say 3/4, but pipe sizes are also strange. And then just tap it out with a hammer. It's not exactly press fit. I mean, it's, it's a little bit tight, but I mean, it's not that tight. So there's one, and honestly, I might just be able to press the other one out by hand. There, see, you don't really need a hammer, or maybe just to get it started, but maybe to get it finished too, I don't know. So now that I have the linear bearings removed, first I just wanted to do a visual inspection and make sure there's no dirt or chips or whatever, anything inside there, and also that they individually move smoothly. Now, these happen to be two different, you can't really test them like that because you see these individual, I don't even know, they're like, if you press on all of these rectangles, then it puts tension, or then it puts a little bit of compression on the ball bearings. So without touching it, you know, the ball bearings don't even really make contact. It's only, and it's kind of interesting design, but it's only when the outer surface is squeezed that the ball bearings make contact. But doing this, even still, it seems fine. You know, there's none that are crunchy or seized or anything. So I think the bearings themselves are fine. I'm going to reinstall them gingerly and try to keep them aligned. They don't take a whole lot of force to get in there. This side I might need to tap that. No? Okay. We're back in. With everything back together, oiled and all that, I think that we have an improvement here. In fact, I think it's about as good as the one below it. It's got some, if I give it some momentum, it keeps going, so it's not binding. That's good. So I'm not sure what it is about taking them out, putting them back in. Maybe over time they I'm not sure, pivot inside there and create some forces and friction, but just reinstalling them seems to put things back into order. So the final thing is going to be cleaning up this threaded rod. You can see there's oil on there, but that's not oil I put on. It was there before, and to be honest, it's kind of sticky and gunky. So it's probably been there for 10 years. I'm going to clean all of that off with likely the isopropyl alcohol, and we'll put something fresh on. So I don't know what kind of lubricant or grease was on this before. I'm sure it's very old now, but as I'm spinning this, I can feel it grabbing the cloth and trying to stick to it. In fact, maybe I can get it to almost hold its own weight. It's kind of, look at that. It's just black and goopy, so I'm gonna remove it all because I'm sure it's not helping stepper motors out any. All right. With all that grease off, it's now spinning very nicely. I like that. And 3-in-1 might not be the best thing to put on, but I kind of like how it's not going to add a lot of additional, you know, if a thicker grease might add a little bit of resistance, but I'm fine with 3-in-1. With a little bit of 3-in-1, this is spinning beautifully. It is reassembly time. I can't wait to see how this thing runs. All right, well, I've got the CNC machine all cleaned and put back together. It's jogging around pretty nicely. Now the real test will be cutting something, and maybe something heavy or tough like aluminum, because that's where I was seeing the issues with the X-axis, skipping steps, and instead of making circles, it would make oddly shaped ovals and rounded squares. But as for now, until I do that test, I think everything is well tuned and the motors are not working as hard. And by the way, you may have noticed I'm using a gamepad to control my CNC, and it is Gerbil, an Arduino, you know. So it was just a little Python program that I made to take the inputs from the computer, inputs from the joysticks, and send G-code commands. And it works pretty well. Anyway, all that stuff is like on GitHub, but I just thought I'd show you that. I'm looking forward to cutting a piece after all these changes and cleaning that I've done. Hope you enjoyed this video. I'll see you next time.